Hi, I'm Jackson.
And I'm Josh.
This is Enigma Explained. Alright, so last video we were talking a little bit about the rotors and how they all fit together and how they're going to work. And so we saw that there's this neat thing called the fast rotor at the front, and then a bunch of other rotors, and we basically keep other rotors from rotating with our alphabet rings, and then we only rotate when there's a notch. So this video is going to be about double stepping and how this whole notch thing actually works. So there's this nice paragraph here in the spec that you should read at some point. You should read the whole thing, but this is going to be the part about double stepping. So basically, this alphabet ring, what it's going to do is it's going to cover the notch and prevent you, or the alphabet ring is going to cover the ratchet, and then it's going to prevent you from being able to lock into the ratchet with the pawl and turn the rotor. So here's an example of what the ratchet looks like, and basically with one of these you're going to have the pawl is this little like pointy thing that's going to click in to one of these things and rotate the ratchet that way. But then next to it you're going to have this alphabet ring where you can see this part's smooth here, and it's smooth everywhere up until this notch on the other side, which I can't, alright, it's fine. There's a notch on the other side. So basically what this is going to mean is that the pawl is going to try to engage, and is not going to actually be able to slip in and engage the ratchet that's next to this thing, because this part here is larger than the ratchet itself, and then the pawl is going to want to like squeeze into this notch, and if it has access to this notch, it's also going to have access to the ratchet right here. So with both of those, we basically get they're side by side, and the pawl is pretty much big enough to be able to slip into either both of them or neither of them. So here's just the pictures up, so we'll have them for reference. What's going to happen now is we're going to talk about double stepping. So typically when we want to rotate these rotors, we can think of a minor example as the rightmost rotor. So the rightmost rotor has this pawl, it's this little pointy thing, and it's going to try to poke and push into the ratchet. So it's always going to succeed, it's always going to have a great time. It's going to lock in and it's going to rotate this thing. Next time you press a key, it's going to lock in, it's going to rotate. It's going to happen every time. Now for other rotors, it's not always going to happen because there's the alphabet ring and the notch isn't always present. It's going to try to lock in, it's not going to make it. There's no notch. It's going to try to lock in, it's not going to make it. There's no notch. At some point, there's going to be a notch, it's going to lock in, and it's going to push both the ratchet and the rotor attached and the rotor that holds this alphabet ring, right? So that's going to be a little confusing at first, but the way it's going to work is, let's say that 5 is always turning, right? And then at some point, 5 turns such that the notch shows up in the alphabet ring just so that 4 can engage. What's going to happen here is when the pawls move next, this pawl next to 4's pawl is going to make it through the notch in 5's alphabet ring and be able to engage with 4's ratchet. And that's going to rotate 4 one step. So it's going to click it over one step, and at the same time 5 is going to move over. And the reason 5 moves over is not just because it is the rightmost and it always turns. Obviously, it's always going to turn. And basically, the other reason is going to be because even if 5 didn't have a pawl here to always turn it, when 4's pawl locks into 4's ratchet and gives it a push, it's also locking in to the notch in 5's alphabet ring. And what that's going to do is, due to the shape of this, it's also going to give 5 a push, and it's going to move that around one click too. So even though all the pawls move in unison and each rotor can only move once per key press, 5 could be moving because of 4's pawl. So that doesn't seem that interesting at the beginning, right? Because 5 is the fast rotor, it's always going to move. But this is going to have further implications later on. Say we rotated 5 enough, that 4 rotated enough, that 4's notch was available for 3. What's going to happen here is even if 5's notch is covering 4's notch allows this pawl 3, to have access to the ratchet for rotor 3. What would happen here is, so we know 5 is always going to rotate, right? Maybe 4 isn't going to rotate because there's the notch isn't open here. But since 4's notch is available, this pawl here is going to slip into that notch and rotate 3. As it rotates 3, 4 is also going to rotate, even though Paul 4 did not have access to 4's notch and was not able to rotate it. So this is called double stepping. What this means is that when a notch becomes available, the pawl isn't going to continuously be able to slip into that notch and keep turning further rotors. What's going to happen is once 4's notch is available and 3's pawl is able to slip into it and turn 3, it's going to happen once. And then 4 is going to get pushed up out of the notch location. And the next key press, this pawl won't be able to engage again because we've moved 4. The next time it'll be able to engage is the next time the notch comes around. If this is the only notch, it'll be 26 steps from now. If there's another notch, it might be sooner. But what this means is that we won't have 3 spinning freely when it really shouldn't be because, we're trying to have 5 be the only one that turns every time. So hopefully that makes a little bit of sense. But here's another way to understand it a little more clearly. It's something I wrote, and hopefully it'll make sense and stick in your brain a little better. But this is the way I like to think about it. So a double step is this. When my pawl, so if I am a rotor, my pawl is the pawl associated with me. It is the pawl to my right. So if I'm rotor 5, this is my pawl. If I'm rotor 4, this is my pawl. If I'm rotor 3, this is my pawl. It's the pawl that's associated with the ratchet for my rotor. So when my pawl is able to engage through the notch in my right neighbor's ringstellung, alphabet ring, so what that means is when 4 is able to engage through 5's ring, when 3 is able to engage through 4's ring, and so on. So what happens here is not only do I rotate, I being the rotor, I also cause my right neighbor to rotate with me. So like we saw up here, if the notch is available, 4 will rotate itself and 5. If the notch is available here, 3 will rotate the 3 rotor and 4. And keep this in mind, at any time step, a rotor will either rotate or not rotate. There is no chance for a rotor to rotate twice, so 5 will never rotate because of itself and because of 4. It will rotate in more of an or sense, computer science. So it's either going to rotate or it's not going to rotate. It can rotate because of its own ratchet or because of its left neighbor's ratchet. 4 will rotate because of its ratchet or because of its left neighbor's ratchet. So that's a little bit about double stepping. It can be confusing. Feel free to talk to a TA or just watch this video again. Hopefully it helps. But yeah, so it's going to be very important later on. We're really going to want to get this down. Otherwise, our Enigma machine will not work as expected. So yeah, thanks for watching.